Okay, let's make sure that we've got everything set up properly, and then we will jump right in. Okay, first let's take a look at our plan for the second semester. We did the singleton, and with that came a big refactor to get the TCP server and client all wired up. And then we're changing things up a little bit. We're not going to do the decorator pattern quite yet. We're going to do the chain responsibility, and then we'll see what structural pattern might work best to wrap up the second semester. And let me just make sure that the Twitch title is correct. Do, do, do. Funny thing about Twitch, it doesn't always want you to edit things where you think you should be able to. Not a huge deal. Okay, and so just a bit of housekeeping. So now we're going to run for about 45 minutes, trying to get everything to be a little bit denser as far as information going out. And I was going back and watching some of the old videos, because this is designed to be kind of like a video series. I'll kind of redo every year and get better at it, hopefully. But one of the things I noticed was, you know, you got 2 or 3 days worth of videos on one topic. It's a lot to get through. All right, so 45 minutes tonight, and we'll see how far that gets us and what we're able to accomplish. Hopefully that'll get some focus in here and we'll knock some stuff out. So now we're going to be doing the chain of responsibility pattern. This is a quick review as to why that pattern came about. We were looking at our hive mind, which we turned into a singleton. And everything's coming through the hive mind. That is, all commands, all login requests, essentially everything having to do with the game is being passed from our TCP client to our server through these strategies, and then the hive mind is asked to execute and then return the game response. So there's a lot of work to do there, eventually, or as we like. But as we come into our execute method, we start to notice that very distinct things are happening, and we're breaking the single responsibility principle because we're asking specialized behavior to happen for login. Let's see, that extends all the way down here. And then we've got our base behavior, which feels pretty concise. That's being asked to do all of the specific execute actions against the game engine. And then down at the bottom, we've got some more specialized logic that is handling the finalized, or the last step of the response, which means pushing it back on the command stack, making sure the player is not null, setting the room content. So as things get more complicated, this logic can get more complicated. And so you've got one method that's doing 3 distinct things, and those things can get bigger and bigger and bigger. And as we saw last time, bugs are going to be very hard to track down. So the chain responsibility pattern is a way to handle those behaviors in a way that allows them to grow independently and in a in a well-organized way so that it's always clear what our application is trying to do and where it's trying to do it. So the definition of the chain of responsibility pattern is to avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle a request. Chain the receiving objects and pass the request along the chain until the object handles it. So, this is going to open up a lot of possibilities, but at its bare, and I'll do this before I show you what we typed up last time, at its simplest, we want to be able to say hivemind.execute. And then we want the hive mind to in some way decide, okay, pass the request to a logon or a login handler. Once that's done, then go ahead and pass the request to a command handler. Then pass the request to a finalize handler or return handler. So, and the chain responsibility allows us to do this automatically. So the login handler will say, after I'm done, I'll pass it to blank. And then we set that. So we say, hey, login handler, when you're done, so if I were to type in login.set successor command handler, and then login dot, we'll just say execute for this, right? Same thing. So what's going to happen is execute's going to fire off the login handler and then automatically fire off the command handler. And then whatever the command handler returns is going to come back out here. So when we get the result, it's actually going to be the result of the command handler. And if we were to tack on the finalize handler, then the result here would be the output of the finalize handler. So it allows us to start to kind of stack and compose the things we want this to do. And it allows us, inside of our hive mind, to have one point of entry, so it keeps things very simple. And the complexity is something that we can change if we want to. We can branch it if we need to. And it becomes very modular. So, what does that mean? So we're on the this kind of very standard Gang of Four derived website that everyone loves, and I'll admit it's a great resource. So, all we really need is this, right? Because we're in the second semester here. We've done a lot of pretty heavy lifting in the first semester, really slowed things down. And at this point, we know that any design pattern really consists of a few basic parts. Those things don't change. We've got some abstraction, right? And that abstraction is the part of the problem we need to isolate. So in this case, the thing that makes all of this work is this concept of a handler. So we need to abstract out that handler. And in this case, in its simplest form, there's a handler, set successor, and then handler request. And this is where we get kind of creative because they're doing an abstract void here to keep things very simple. We're going to have that actually return back a game response. So let's look at our code. And if we're inside the server, and we've got our hive mind process strategy, right? So these are the 2 points that are talking to each other. So the client has its command strategy that's talking to this server's process strategy, right? Let's open that guy up. And some lifting's going on here because this endpoint, its entire job is to take a request that comes in our case we define it as a console request, and then change that into something that the game engine can understand. So we've got quite a bit of logic here to make sure that happens nicely. This is its own piece of refactoring and cleaning up and really making nice and robust. So we aren't too concerned right now. As long as we're getting it, as long as we're getting that game request, we won't come back in here unless there were bugs like there were last week. So we don't want to put our handlers here, right? Since all this is doing is marshalling or unboxing and and reboxing, whatever phrasing you want to use. All this is doing is transposing, for a third term that could work. All this is doing is transposing what comes in into something that's actually digestible by our hive mind, which is here. So inside the game engine, we're going to go ahead and add a new folder. So inside the game engine domain, and these are going to be handlers for the game engine. So maybe they're useful at other places, but for right now, we're really just focused in on them being of use by the hive mind's execute, right? So let's go ahead and add in a new item, and we'll call this base handler. I like to use the word base to denote an abstract class or anything I'm going to derive functionality from. Okay. So we got a public abstract class called base handler. Let's come back over to our Game 4 website. The only thing we really need is this guy. So it's simple enough that we're just going to go ahead and copy it. I'm going to go ahead and make this base handler. So this is our successor. And we will follow the resharper kind of guidance here and rename that to successor with an uppercase S. Okay. We've got a method which sets the successor. And again, we'll make sure this all follows our naming convention. And then we've got an abstract void that is handle request. And so we're going to make this our own, right? So instead of void, we want to be returning back a game request. Or probably a game response. We'll challenge that logic here in a second. And we're taking in a game request. This should make sense, but if it doesn't, it'll become glaringly obvious in a few minutes. All right, so if I return everything out, this few lines of code, 1, 2, 3, 4, right, in a base class, is all we really need to set up the abstraction for our handlers. It's nothing crazy, nothing scary, nothing more complicated than that. That's all we really need. So, if we look at the code here for the concrete handler, in our case this would be login. It's going to override the handle request. In this case it does nothing. But at the end of handle request, it calls the successor. This is where you start diving into the rabbit hole. So then this guy can call successor, and then that guy can call successor, and then that guy can call successor, right? And on and on and on and on. So because we're returning a game response, we're going to expect every successor to do the same. So if we come back over here, let's add our first concrete handler. I'm going to call this the login handler. .cs. And say public class login handler is going to inherit from the base handler, and resharper is queuing off that we're missing something. So we're going to let resharper implement the missing members. We'll remove our unused using statements, kind of clean things up. And then we've got this handle request, right? And so